So today, we need to talk about data distributions. I'll put a PDF of these notes right next to the video, which is going to be with the homework as well. So I'm going to get you everything you need to be able to do the homework, but I also don't want to just throw you a bunch of ways to do stuff. I want to explain what's going on. So when you look at a data distribution, you have to look at its shape, its measure of center, its measure of spread. So shape, center, spread, and then you also want to look for any outliers, okay? So I'm essentially giving you a little like an AP approach to this, which you're not going to get from the other classes. But it's really good because if we're going to talk about statistics, you really need to get the whole picture, right? We'll be able to do it in a very short amount of time. I can condense it for you, okay? All right, measures of shape. It's either going to be skewed or approximately symmetric. Hey, what does that mean? It means this, and I'll come back to this, okay? So let's look at shape. If your data, if I was to draw a histogram of the data and it looked like that, okay? You would say that the data is skewed. And specifically, you would say that it is skewed right. It's kind of weird because you would think left, right? Since all the data is over to the left, but it's actually skewed right. And the reason that it's skewed right is that when you have all your data over the left, it turns out that your mean, remember we said that was X bar, actually gets pushed out away from your median. And I actually need to write that mean. So you would wind up with your median here. So your median is going to be closer to the center, the actual real center, than your mean. All right? And that's why it's called skewed right, because what happens is your mean gets pushed to the right. When your data is mostly sitting over to the left, your mean gets pushed to the right. When you have data that is mostly over here on the right-hand side, we would say that it is skewed left. Left. Fantastic, guys. You know those left and right. The reason why it's said that it's skewed left is because what happens is your median is going to be a better measure of the center of the data than your mean, because your mean gets pushed out to the left. All right? The other case with shape of data is that it is approximately symmetric. If your data is exactly symmetric, what you're going to wind up with is your mean is going to be exactly the same as your median, okay? If it's exactly symmetric, right? Normally you'll say that a data distribution is approximately symmetric. If it's exactly symmetric, though, our mean is going to be equal to our median. So that is a measure of our shape. All right? Measures of center. Measures of center are your median and your mean. Those are the things that we use to measure the center. What's the average? Right? You want to know an average data value. You would either look at the mean, if your data is approximately symmetric, or if your data is skewed, you would use the median actually to describe what a typical score would be or something like that, right? Measures of spread are standard deviation and interquartile range, which we call IQR, stands for interquartile range. All right, so let's talk about what is the IQR. And we'll go ahead and go below this, because that's probably what your notes look like. So IQR, interquartile range, all that is quartile 3 minus quartile 1. That's it. We talked about what your quartiles are yesterday, right? All right. You don't really need to know what this is. You don't really need to know a lot more about it. I just want to give you a complete description of one variable statistics. All right. Okay. We look at outliers. Outliers are unusual points, right? They're usually very, very far away in the like the very high values or extremely low values. There's actually a way to calculate whether they're technically an outlier or not. But we're going to look at these. We're going to call these extreme values, right? So in other words, they're going to be either very high or unusually high, right? Or we could say, I'll say unusually low. Whoa. All right, so now that we've talked about basically what we look at for data distributions for one variable data, let's move on and talk about a specific type of distribution. It's called a normal distribution. All right? Right through here. So now we're prepared to talk about a normal distribution. The normal distribution, it looks like this. A lot of times you'll hear someone refer to a bell-shaped curve. There it is. With a normal distribution, it is exactly symmetric. So that means that your mean and your median are exactly the same. So this line represents both your mean and your median. Now remember we had said that we were using x bar as mean. For a normal distribution, that is the mean of a normal distribution. It's capitalized. Okay. So now we just have a new new bit of notation that we're going to use. All right. So our standard deviation. So we'll mark that as being 1 standard deviation above the mean, negative. Sigma will be 1 standard deviation below the mean. And then we can have negative 2 standard deviations below the mean, and then also negative 3 standard deviations below the mean. We'll also write the same thing over here. This will become significant in a little bit when we talk about the standard normal distribution. All right. Some properties of this. The area underneath this curve is equal to 1. All right. Another property, like I just said, it is exactly symmetric. Over here, these tails go on and on and on forever, and they never ever touch this axis. Okay. There's actually a function that represents this, like you could graph it in your graphing calculator, but it's very weird. I'm not going to deal with it. So, but anyways, just realize it's a function. Okay? All right. So it turns out that there is a formula that we use in order to calculate the area under curves, and it is z equals x minus mu over sigma. Okay? What this does for us, what z is, z tells us, whoops, not equals, but z tells us how many standard deviations from the mean a particular value is. And we would represent that value as x. So we call that x. Okay? Alright, so in this case, we'll look at the standard normal distribution. Has a picture like this, okay? Remember, this is our mean, right? How many standard deviations from the mean is our mean? 0, right? And then we'll have another value at 1 standard deviation from the mean, negative 1 standard deviations from the mean, negative 2 standard deviations from the mean, negative 3, and then 1, and 2, and 3. This will all make sense when we start doing problems, okay? I'm just laying some groundwork for you, though. Giving you the kind of theory behind using the normal distribution to calculate a proportion or a probability, right? So we use that z, and that z will tell us, we'll get an area from that z, right? So let's actually do a problem and calculate it, and we'll see. All right. So, let's assume that grades are normally distributed. With a mean score of, let's be realistic, 71%. And a standard deviation of 3%. All right. We are going to find the probability that you choose a random student, that you randomly choose a student, and that student has a 60%. Okay. We can also say what is the proportion of students that have a 60%. All right, let's break this thing down now. All right, the things that we really need to know in this are our mean, our standard deviation, and our x value, okay? So this guy right here is our mean. This right here is our standard deviation. And this is x. The reason why I need to know that is I need to plug it into this formula. Z equals x minus mu over sigma. All right. So in this case, I already said what x was, right? It's 60. I know what my mean is. I said it was 71 or 70? 71. And sigma, or our standard deviation, was 3. I don't necessarily need to calculate this because I'm going to show you guys a calculator first. There's a more in-depth way of doing this using a table, but I'm going to show you how to do this with your calculator. The most important thing that you can do, though, so when you do this, first thing you need to do is identify your mean, your standard deviation, and your x value. So we've already done that, yeah? Then we need to draw a picture of our desired area. So what we're going to do, the answer to this question turns out is just an area underneath our normal curve. Our calculator will spit it out for us, okay? So our mean here is 71. We're looking for an x value of 60. And what our calculator is going to do for us, what we're going to make it do, is find the area of this shaded region. The area of this shaded region is both the proportion of students that got a 60% or lower, and the probability that a student gets a 60%. All right? So what we're going to figure out is the probability that x is less than or equal to 60. And we're going to get our calculator to do that. Here's our steps. All right? And I'll write that over here. Calculator steps. All right, you are going to hit second vars. What that is that's distribution. And I'm pretty sure it's just D-I-S-T-R. D-I-S-T. All right? So let's do it real quick. So our first step, we're going to hit second vars, okay? We're going to scroll down to, oh, my bad. Sorry, I was about to give you the lesson I did for AP Stat. So I'm doing statistics, 2 different distributions right now. Sorry. So I'm going to choose normal CDF, okay? All right? So that's 1. 2. Choose normal CDF. All right? Looks like this right there. Or 2, right? I hit that. It gives you a lower and an upper bound. So it says, hey, what area do you want me to find? Between where and where do you want me to look? Because calculators, they're only as smart as the user, right? You have to tell them everything to do, or they don't get it, yeah? So if we look at a picture of this, let's look at a picture of the area we're trying to find right now. That area is right here, right? But check it out. This thing, this line, remember I said it keeps going on and on and on forever and ever and ever. Never touches this line. So there are x values over here as low as negative infinity, right? Your calculator can't handle that. It does not know about infinity. It can't ever know about infinity because it's not a human. Then we're probably in trouble because have you ever seen Terminator? So what you're going to do is you're going to tell your calculator, hey calculator, we know you don't understand infinity, but how about something really, really close? So this is the closest to infinity, negative infinity rather, that your calculator can comprehend, is negative 10 to the 99th power, right? And that is very, very, I mean, it's a very, 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 very negative number, right? So we tell our calculator, hey calculator, let's do negative 10 to the 99th power as our lower value. And our upper value we'll choose is going to be our x value, right? We said that we want to know about scores of 60. Our mean we said was 71. Huh? No, it's okay. This is the same thing. All right. This is the important part. Okay. Knowing how to make your calculator do it. So, we said our standard deviation was 3. And we paste it. Okay. If you have a TI-83, when you hit the command normal CDF, it just brings up the normal CDF and the parentheses. What you need to do is you need to type in, you actually have to type in lower, and you can put negative 10 to the 99th power there. This is your mean. This one's your standard deviation. My bad. Sorry, it's x. This is x. Mean. Standard deviation. That's how it goes, okay? If you have an 84, it should give you this many. Alright, so I hit enter. And I get a very, very small number. This is approximately 0.1234, and then we can just go. So it turns out that if my standard deviation is only 3, it's actually highly unlikely that someone got a 60%. All right, so there's our first calculation. And we'll put that number here. 0.000, was it 123? 123. 123. 1, 2, 3. That's very, very, very unlikely, right? If this is your tens, hundreds, thousands, 10,000, you could say it's around a 1 in 10,000 chance. It's very low, right? That's how you would interpret that in terms of a probability. Okay. What if we wanted to know the probability of getting above a 75? What's the probability that you get a 75 or better? All right. So let's look at this. What is the probability? Or in this case, let's talk about what proportion of students scored 75. All right, we have a different shaded region for this. If we set a 75 or better, terrible looking curve, sorry. We draw our distribution. Our mean is 71. And we're looking for a 75 or better. Well, that's this shaded area, right? So in order to do that, we use our calculator. And we're going to use the normal CDF again. So again, second distribution, normal CDF. And now our lower bound is not going to be close to infinity, right? That's going to be our actual x value that we chose. So our x value we said was 75. And our upper value, right? If we look at it, we're looking for an upper value because this goes way, way, way out here, right? All the way out to like positive 10 to the 99th power. So we can put 10 to the 99th power in there. That's a very, very big number. Our mean is still 71, our standard deviation is still 3, right? So we can hit paste. Enter. And that's actually a bit better probability, right? Since our standard deviation is so low, right? What that means is that most of the students scored right around a 71. If our standard deviation was bigger, this thing gets spread out, right? Which means that the scores had more variation. There were a lot more different scores. Where our standard deviation is really low, that means that the scores were really close to the actual mean score. All right. So our answer to that is about 0.091. So we'll say. So you could write it in this way: the probability that x is greater than or equal to 75. 0, 1. Or you could say, in terms of a sentence, about 9.1% of students scored above 75. Okay, last thing we need to calculate. Last thing we need to calculate. What if you were asked, what percentage, and I can ask these questions, I can interchange these. I could say what proportion of students scored this well, what percentage of students scored this well, what is the probability that a student scored this well. I can use those interchangeably. So I could say what percent of students scored between 72% and 69%. Again, the first thing I should do, we've already identified x, our x value, our mean, and our standard deviation. So the next thing that we need to do is we need to draw a picture of it. It really, 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 really helps when you draw a picture of it. And most questions that'll ask you to use normal distribution to calculate a proportion or a probability, they're also going to require this picture. If you don't have the picture, you'll lose points. So our mean was 71. We keep trying to say 70. It's not true. Our mean is 71. Our one x value we have over here is 69, and our other x value is 72. Now, based on what I said about the standard deviation, what do you think? Do you think this is going to be a really high probability or proportion, or a really low? This shaded area. Think it's going to be close to 1 or closer to 0? Because it's got to be between 0 and 1, right? Because it's a probability. Huh? What do you think? Big or small? Pick one. Tall? You can talk. It's okay. You can talk about talking in context of math. It should be pretty big, right? It should be pretty big. All right. Let's go ahead and go to our handy dandy calculator. We're looking for the probability that x is between 69 and 72. We'll go to our handy dandy calculator. We'll go and hit second. Bars, we'll go to normal CDF. And now our lower is actually the value that we're looking at, 69, right? And our upper is our upper value we're looking for, which I said was 73. 72. So this will become 72. And all of this other stuff stays the same because we're doing the same problem. Oh, it's fairly high. It's not that high. I thought it would have been a little better than that. But that says that around 37.8% of students scored between a 69 and a 72. Number 0.378. So, and we have to say that's approximate, because I did approximate. Can I do that up here too? Sorry, this should be, if we round, I need to use an approximate symbol. I did round. Sorry about that, guys. Alright, so around 37.8% of students. Well, that's not a sentence. Scored between 69 and 72. Cool. That is it in a nutshell, guys. That's it. If you can do these, you can do all of the homework, and we're pretty much in the home stretch. Alright, so I'm going to post this lesson, a video of it. I'll post your homework, and yeah. Alright. Thank you.